Okay, now I think it's recording. Okay, perfect. All right, guys. Let's start with let's see, let's start with the number one. I mean, unless there are any specific requests, I mean, I can always start with a different number, but I mean, it's up to you, of course. But yeah, I guess start with the
Could you
number
start
one.
in order of the lessons?
Oh yeah, yeah, I'm recorded. Yeah, the session, yes.
No, I said, can you start in order of the lessons,
Oh,
like
the last.
5.2, like the last one first?
Okay, last one first. Okay. Uh, last one first. So the last one would be chapter. That would be chapter 7. Chapter 7. So we have sections 7.1, 0.2, and 0.3. All right. So let's see. So this is problem number 3, right? So as I said, this is very similar to the problems in the homework number 6. So this is problem 3. So this is similar to the problems. So in the homework 6, you have like, so let's see, you have 3 exercises in the homework 6. And 1, 2, yeah, I mean, yeah, this is very similar to the exercise 1 and 2, I would say, 1 and 2. So this is similar to the problems or exercises 1 and 2 in the homework number 6. All right. So problem number 3. So it says you have a random variable. So x represents the length of time it takes to, so the variable x, that's the time or length of the time it takes to student to write a term paper. To write a term paper. So, and we know that the variable x has a mean mu equals to 6.8 hours. So mu, the mean, that's equal to 6.8 hours. And the standard deviation sigma, standard deviation. So sigma, it's actually equal, so it's 2.1 hours. Okay. So that's the mean and the standard deviation. All right, so first question. What's the probability that it takes less than 6 hours for a student to write a term paper? Okay, so so 1, what's the probability that it takes less than 6 hours? Probability. So what's the probability that it takes less than 6 hours? It takes less than 6. Less than 6 hours for a student to write a term paper, right? So we want to find the probability, right? The P. So we need the probability that it takes less than 6 hours. So you need your variable x. Again, the x, that's the length of time it takes for a student to write a term paper. So you need your x to be less than 6 hours. So that would be probability that x is less than 6 hours, right? So less, it's less. So less, so this symbol here means less. So x is less than 6 hours. All right, so there are two steps, right, to compute such a probability. First step, so step one, we need to convert. So step one, so you need to convert x to z, right? The variable of the standard normal distribution, right? So that will be probability that z. Okay, so I'm going to change the variable. Instead of x, we use the variable z, the variable of the standard normal distribution. And then we need to convert 6, right? So 6, it's a value of x. Now we need to convert 6 to some value of z, right? And the formula to convert x to z, I'll just remind you. So x, sorry. So, oops. So, so let me just write down here the formula to convert x to z. So z is equal to, I'm going to use a red. So z is equal to x minus mu, the mean, over sigma. Okay. So this is a value of x, and you want to convert this to z. So, so it's like saying your x in the formula is 6. Now mu, the mean, it's given. Of course, that's the 6.8 hours, right? This is given. And the standard deviation, it's also given. It's 2.1, right? So that will be 6 minus 6.8. That's the mean. And then over the standard deviation, which is 2.1, right? So that will be probability that z is less. So 6 minus 6.8, that will be negative 0.8 over 2.1, right? So then there will be probability that z is less than. So then you need to divide, 0.8 or negative 0.8 by 2.1, right? By 2.1, and then so the answer would be actually this is negative 0.38. Yes, thanks. All right. Now that's the first step. So you convert your x to z. Now, so this is very similar. So like in the homework, where's the homework? Like in the first exercise. And now in the first exercise, if you take a look to the first exercise, you have your mu, you have your sigma, and then it says like what's the probability that the thickness is less than 3 millimeters, right? Etc. So if it's less, then your x is less than, like in the exercise 1, it would be less than 3.0, okay, etc. Anyway, so this is the first step. Now, second step, you need to use your table. So this is step number 2. And this is where we use our table number 3. Because again, the idea is our table number 3 gives us the, the areas and probabilities for any value of z. So z less than negative 0.38. So if you check your table number 3 in the formula sheet, don't forget your formula sheet in the ones there, right? I can probably provide you guys with a formula sheet. So yeah, so this is negative value, right? So that's negative. So the nearest, nearest 10th, nearest 10th, that will be negative 0.3, and nearest 100th, that will be 0.008. 0.008. All right, so negative 0.3 and 0.08, that will be 3520. So the answer is 0.3520. Okay, so let me explain. I mean, I don't know if you're, how to use the table, guys, but this table number 3 in the formula sheet. So this is supposed to be your z, and then you have like negative 0.3 in the bottom, right? It starts with a negative 3.4, right? And then I guess I have to unmute someone. I'm sorry about that. All right. So, and then in the nearest hundredth, you have like, this is like 0.00, you know, 0.01, etc. But then you have like 0.08 and then 0.09. So anyway, so nearest hundredth, nearest tenth. So the answer would be here. That's negative. That's 0.3520. All right. So in other words, this is 35.20%. Okay, so you take two digits right after the decimal point. Is there any question, guys? So that's for number one. Now next, let me see next. So it says, what's the probability it takes more than 7.2 hours for a student to write a term paper? So more than 7.2, that's larger than 7.2, right? When we say more than, this is number 2. So it's more than 7.2. Okay, more than means it's larger than. Okay, and you know, on the number line, this is 7.2, larger than 7.2 or more than 7.2, that will be the right side of 7.2, right? The area to the right of 7.2. Anyway, so we need the probability that x is larger than 7.2, right? This is, the symbol here means larger. Okay, and as I said, that will be the area because it's larger than 7.2. So that's the area to the right. To the right of 7.2. Okay. So, well, as usual. So step 1, we convert x to z. Step 1, convert x to z. Right. So this is probability that z is larger than. So 7.2. So it's 7.2 minus mu, the mean, which is we said it's 6.8 over the standard deviation, which is 2.1. So minus 6.8 minus 6.8 over 2.1. So this is probability that z is larger than point. So the 7.2 minus 6.8, that's 0.4 over 2.1, right? And then of course we divide. So this is probability that z is actually larger than 1. Yes. Yes, you're right. So this is, yeah, as you said, so this is 0.19. Okay. Now, so I converted my x to z. All right. So next step, I'm supposed to use my table, right? But the thing is, the table gives us the areas to the left, only the areas to the left. This is the area to the right. It's the area to the right because x is larger than 7.2. So x is like on the right side of 7.2, right? When it's larger, so you're on the right side of 7.2. So this is the area to the right. Now, as I said, the table fee gives us the area to the left. So the idea is that the total area is 100%. It's 1. So the area to the right would be always 1 minus the area to the left. So the area to the left, this is when z is less. All right, so this is z is less. So this is less. So this is the area to the left. Okay, because the area to the right plus the area to the left, though, that's always 100%. That's equal to 1. All right, so now I can use my table. Once I have the formula in terms of the area to the left, I can use my table number 3. All right, so 1 minus. Now table number 3, it's a 0.19. Nearest is
57.
0.1. Sorry, Jenna, I have to check my my table. So 0.1, and then nearest hundredth, it's 0.9. So the answer is, this is 1 minus point. So this is positive, right? 5753. Okay. So the answer would be, so this is 4, then 4, then 2, and 4 point. So the answer is 42.47%. Right. And again, you take 2 digits after the decimal point. That'll be your percentage. Let me check if there are any questions in the chat. Okay, no questions. All right, so this is the area to the right. So again, you need to keep in mind the area to the right, that'll be the area 1 minus the area to the left. Now, the third case, this is when you have a probability between 2 numbers. So we have, so 3. So what's the probability it takes between 5 and 8 hours for a student to write a term paper? So in 3, it's between. It says between, right? Between 5 and 7. Sorry, between 5 and 8 hours. Okay, so we want probability that X is between 5 and 8. All right, so as usual, step 1, convert X to Z. So this is probability that, so 5 minus 6.8 over 2.1. This is Z now. And then 8 minus 6.8 over 2.1. So this is probability that, so this is negative 1.8 over 2.1. This is Z, then less than, this is 1.2 over 2.1. Okay, so we divide. So this is probability that, so we divide, let me see my notes. So we divide, yeah, so we divide 1.8 by 2.1. Right, so that's equal to actually 0.857. So we need to round the answer, I guess. So that will be 0.86.
Professor, there's a minus sign.
Oh, minus, thank you. I appreciate it, thanks. And then we divide the 1.2 by the 2.1. So that'll be equal to, of course, 0.57. Right. Now, this is the area between 2 numbers. It's not the area to the left of just 1 number, or the area to the right of 1 number. It's the area between 2 numbers, right? So what I'm talking about here is, this is the graph of your graph of your distribution, and then you have your negative 0.86, you have your positive 0.57, and so you need the area between these 2 numbers, right? So we said, so for the areas between 2 numbers, it's always the difference between the areas to the left of the 2 numbers. So this is the area to the left of, so Z less than 0.57. So because it's less, then this is the area to the left minus probability that Z is less than the other. So the Z less than negative 0.86. So again, this is, because it's less, this is the area to the left. And that's because, again, guys, you see, let's say this arrow here represents the area to the left of 0.57. Now, the area to the left of negative 0.86, that'll be this one here, right? Let's say the yellow arrow represents the area to the left of negative 0.86. And then you can see the difference between the two areas. It's exactly this area right here, right? Between these two numbers, right? So this is exactly what we want. Right, the difference between, so you see the difference between the areas to the left, that will be exactly the area between the two numbers. And now, as a second step, I can use my table, right? Because I have everything in terms of areas to the left. If you have everything in terms of the areas to the left, then you can use your table, because the table gives us only the areas to the left. All right. So for 0.57, nearest tenth is 0.5, and nearest hundredth is 0.7. So that will be 7157. And this is 0.7157 minus negative. So be careful, guys, right? The first page is in the table fee, it's for negative values of z. The second page is for positive values of z. So negative 0.86. So nearest tenth would be negative 0.8, and then nearest hundredth would be 0.06. So that's 1949. 1949. Okay. So yeah, so then the answer would be 8, 0, 2, and then I guess 5 point. So that's 52.08%. Right? Any questions so far? Let me check the chat. Yeah, so that's exactly the same, like in the exercise 1 in the homework 6, it's exactly the same thing. So first you have like the area to you have like less than 3.0, and then you have like where is it, more than 7.0, and then between 3.0 and 7.0. So that's exactly like first exercise in the homework 6. Now the question number 4, which is different, kind of different from the previous questions. So here we need, so how many hours? It says how many hours. So when I say how many hours, the variable x is supposed to represent the number of hours, right? That's the length of time. X, the variable x, that's the length of time, right? In hours. In hours. So when I say how many hours, it means that we want the value of x. Okay, because x represents the number of hours. So we want x. And then it says how many hours it takes for a student to write a term paper at a probability of 95%. So we want x, says that the probability is 95%. So we want x as that. So remember, guys, that the area to the left, that's exactly the probability that x is less than some value, right? So we want x as that 95% of the distribution, of this normal distribution, lies to the left of x. To the left of x. Okay, so in other words, we know that probability of that x less than some number. So this is the unknown. Okay, this is an unknown. Is actually equal to this 95%. So the 95%, it's not x. It's not your variable. 95%, that's the probability, right? That's the percentage, or that's the area. So for which value of x, probably that x less than that value is actually equal to 95%. So first step, there are 2 steps here. So in this kind of problems, so as a first step, you need to find the corresponding z. Find z corresponding to the 95% from the table. corresponding to 95%. Right? And then in the second step, we're going to convert Z to X. Right? So this is like, so in the previous problems, we converted X to Z, right? Now, in this problem, we need to find corresponding Z, and then we're going to convert Z to X. So what's the corresponding Z to 95%? So what we do is we need to take a look to our table, P, and we need to find the corresponding Z. So so we need to find first where's the 95%, right, in the table. So the numbers in the table are increasing, right? So the first page in the table you have negative value of Z, and then second page you have positive values of Z. But anyway, so the numbers are increasing, and we are looking for point. So 95%. This is 0.95, right? So we are looking for the corresponding Z to 0.95. Now, in the first page, if you check the values, the probabilities, so it's like from 0.0003, and the largest value, it's like 0.4641, right? But we need 0.95, so that's larger than 0.46. So now for the positive values of Z, you can try to find 0.95, and as I said, the numbers are increasing. So you can see so you have where is it? Yeah, here you have 0.9495, and then you have like 0.9505. So this corresponds to, so here we have like, this is Z, of course. Here you have like 1.6, right? And here on the top you have 0.04, and this is 0.05, right? And 0.95, of course, it's actually exactly in the middle of these two numbers, right? This is we need 0.9500, in other words, right? So it's exactly between these two numbers. Okay. So we need X, sorry, we need the Z. So we're gonna take, yes, please.
I have a question, please. I'm sorry.
Yeah, sure.
We're looking for 1.6 or for like 95?
We are looking for 0.95.
Yes.
95%.
Okay.
95%. 95%. 95%. That's 95 over 100. So
Yes.
that's 0.95.
Yeah.
Okay.
Okay.
Or that's the same as 0.95. 00. You can put as many zeros as you want, right, after the 5.
Because
Make sense?
like when I was looking for 0.95, I got like 8264 and 8289.
No. Okay. I think okay. I think you're confused a little bit here, because we are looking for Z. We don't know the Z, right?
Yeah.
It's not. We don't know the Z.
Okay.
So
okay.
we are trying to find this 0.95 inside the table, not in the first not in the first columns where you have the value of Z.
Oh,
So here it's inside the table.
Oh.
You don't know the Z. You don't know the value of Z. So you don't know what's the value of Z in the first column, right? You
Yeah.
have the values of Z. You have like 0.0, 0.1, 0.2, etc. Right?
Yeah.
So you don't know the Z actually. So
Okay.
you need to find the 0.95 inside, like inside the table. And then, so like in this case, we can take, for example, so this is this value here, 9505, which is that's the closest one to the 95. So the corresponding Z would be like it's 1.65. Okay, so corresponding Z Z is 1.65, let's say. Okay. So again, the 95% of the 0.95, it's not the value of Z. That's the area to the left, or the probability, right? So now, once you have the value of Z, you can convert. So that's step number 2. So once you have the value of Z, you can convert Z to X. So now we can convert Z to X. And just to remind you to convert Z to X, so then X is actually Z times sigma plus mu. So you know Z, you know sigma, you know mu, so then you can compute the X. So X would be Z, which is 1.65 times the sigma, which is, let's see, what's the sigma in this problem? 2.1, right? Plus the mu, the mean, that's 6.8. Okay. Don't forget your PEMDAS rule. You have to multiply first, right? So then that will be equal to, so 1.65 times 2.1. That will be equal to, this is 3.465 plus 6.8. So the corresponding Z is plus 6.8. So that will be equal to 10.265 hours. So what we are saying here, guys, I mean, of course, this is the answer, but the interpretation of this number. So what does it mean, this 10.265 hours? It means that there is 95% chance that the student finish his term paper in 10.265 hours. Okay, so what I'm saying here, so interpretation. So this is not including the answer, right? Just to understand the numbers here. So what we are saying is, so there is 95% chance that that a student finish his term paper, writing his paper in 10.265 hours. Okay. So, and this is actually exactly like in the, exercise number 2 in homework 6. So in homework 6, exercise number 2. So number 1, so you need to find the probability that X is less than 2 years or 24 months. 2, you have the, so Acrotime doesn't want to make refunds on more than 12% of the watches it makes, right? So the 12% in the homework 6 exercise 2 represent the probability, right? So first you need to find the corresponding Z and then convert to X. Any other question, guys, about this exercise? So this is actually this exercise cover.
Are you gonna go through another example?
Oh yeah, sure. Another example. Well, I'm because I need to cover all the problems in the review sheet, right? So I guess I'm gonna do like different. I mean, I'm gonna do next. Let's see. What will be the next problem in the review sheet? So, or the previous section. So this is a chapter 7. So yeah, I can. I'm gonna do the problem number 2.
Okay.
Okay, but I mean, you can. I mean, if you're looking for more examples, you can try to watch the recordings, right? On YouTube. You can try to watch the recording, and you can probably find a lot of examples there. I think there is another questions. So, how many questions will be on the test? Well, let me see the test. Let me see the test. So you're gonna have actually 3 problems, just 3 problems. But of course, like in each problem, so the first problem is gonna cover, first problem is gonna cover chapter 7, let's say. Second problem is gonna cover chapter 6, and then third problem is gonna cover chapter 5, right? And in each problem, of course, you can have like, 2 or 3 different questions. Like this one here, you have like 4 different questions, right? But yeah, in the test, you're gonna have like just 3 problems. Each problem cover 1 chapter. So let
Hi,
me do a
excuse
different
me. I have
chapter.
one more question.
Yeah, please.
So, do you know, can you tell us what chapters the test will be covering? It's just 5, 6, and 7.
Oh yeah. Oh yeah. I mean, if you, I don't know if you have the review sheet in front of you, but it says like the test. So the test covers, 7.1.2.3 from chapter 7, and then 6.1, 6.2, 6.3 from chapter 6, and then 5.1, 5.2 from chapter 5.
Okay, thank you.
I mean, if you just take a look to the review sheet, it's everything is there, I think. Let me see. Yeah. All right. So let me at least solve one more problem. We don't have time. Time really goes really fast. Yeah.
Let's go over the problem number 4.
Problem number 4. The
Yeah.
probability rules.
Yes.
Okay. Yeah. Sure. I can do that. All right. So let's do the 4, and then I will do the 2, and then if we have time, we'll do 1. Okay. So yeah, exercise 4. So again, this is from the review sheet. All right. So this is probability rules. So you have this committee on student life did a survey of 417 students regarding satisfaction with the student government and class standing. So we have the results. I don't know if you have the table in front of you guys, but it's going to take me like 2 minutes at least to write down again the table. But I can do it probably, I guess, very quickly. Does everyone has the review sheet in front of him?
Yes.
Yes, Professor, because it's gonna
Okay, you
take
have it. Okay, you have it. Okay, cool. Okay. So for example, we want first to find the probability that the student selected at random is not satisfied. So first, we need the probability that a student is not satisfied. Student selected at random, of course, it's not satisfied. Not satisfied. All right, so how do we compute such a probability? You need to keep in mind, guys, your answer, whenever you compute a probability, your answer is always a number between 0 and 1. If your answer for a probability is not a number between 0 and 1, then it's incorrect. All right. So not satisfied. So to find the probability, guys, in this case, all we have to do is, the probability would be given by the frequency of the event over the size of the sample, right? So just to remind you, so in general, to find the probability, that will be equal to the frequency. So how many not satisfied students, so that's the frequency of the event over the size of the sample. So how many students in total we have, right? Size of the sample. So like in our case, we are interested in student not satisfied, right? So the question is, how many not satisfied students? Yeah, you can check the table and you can see the total number 71, right? Like in the first row, the total of not satisfied is 71, right? So it's 71 over where we are selecting a random student, and the total number of students, it's 417. So it's 71 over 417. Okay, so you see, guys, this is the size of the sample. That's the total number of students. And this is the number of not satisfied students. That's the frequency of the event. How many not satisfied students, right? Anyway, so you divide 71 by 417. Now, next, you have probability that a student selected random satisfied given the student is
Sophomore. What happened?
Hello?
Yeah, it just froze. I can't hear him.
Me either.
I thought I was the only one. Oh, maybe he doesn't know. Yeah, it froze. Oh my god. This can be happening. Okay.
all right. I'm sorry about that, guys. I guess for some reason the Zoom froze on my iPad, so I need to. All right.
Mister, I can't see your screen.
Okay.
It's just frozen.
Okay. Do you see the screen now? Nope.
Yeah,
Yes.
I see it now.
Okay. All right. Sorry about that.
It's okay.
It happens sometimes. All right. Oh, okay. There's a problem with why there's an echo. Um,
Hello?
yeah, I'm trying to fix the problem. I don't know why the um okay. All right. I don't know why there's an echo here. This is weird. Okay, I'm gonna just share. Oops. All right, guys. You know what? I'm gonna just let me see what I can do here. Yeah, I'm gonna stop the meeting and I'm gonna record, I guess, again the session. So I guess that's a problem here. I'm gonna just stop recording for 1 second.